Hey everybody, welcome back to AP Physics C, and we're going to continue doing some 1D motion or 1D kinematics practice. So the best thing you can do is just kind of look up practice problems if you want to prepare for a test on a 1D motion. So last video we went over a really basic problem of just like a car moving at a certain speed and then a certain acceleration. So before we look at this problem, which actually is two particles or two objects instead of one, there are a couple things I want you to note down. I'll note them down here on the side. So one, the equations that were mentioned in the previous video only work, so the equations only work when acceleration is constant. So you'll notice in the previous video, acceleration was a constant. It was just a number. There was no variable. It was like 5. It wasn't like 5x or something like that. So these equations will only work when the acceleration is a constant, which means that you'll be moving at a constant velocity. Now, it's important to note that when acceleration is not constant, you'll have to use calculus-based methods like derivatives and integrals. That's why I wanted you guys to go back to the previous videos and solidify your knowledge on the relation between position, velocity, and acceleration. So that's what you're going to use when acceleration is not constant. And number two, there will be some problems where acceleration is not given, but you don't need to solve for it. Now why? Because an acceleration of an object due to gravity, we can call this g, or a, is going to be 9.8 meters per second squared. So for example, if you just hold an object in the air and it falls down, it's automatically accelerating at 9.8 meters per second squared due to gravity. Now this is a really important thing to note down, because there may be some problems where they drop an object in the air, but they don't tell you the acceleration, and there's actually no way to calculate that. So instead of getting stuck on that, you should know that at that point, acceleration should be 9.8 meters per second squared. So now we're going to go ahead and tackle this problem. Now we have two particles taking off at the same point at the same time. Particle A starts out moving at 5.5 meters per second. Particle B at 3.1 meters per second. Particle A has an acceleration of 2 meters per second squared, and B has an acceleration of 4.7 meters per second squared. So at what time does particle B pass or surpass particle A? So once ahead, let's just go ahead and note down the information that we have. So let's split this into particle A and particle B. Since we have two objects, we want to list down their information separately. So for particle A, well, we know that they take off at the same point. So we'll call a reference frame x of 0 to be 0. So we're going to call the starting point where they're at just 0 meters. And they both start out at that same point. So particle A will start out moving at a velocity of 5.5 meters per second. So your initial velocity is 5.5 meters per second. And in this case, your acceleration is given to be 2 meters per second squared. For particle B, your initial velocity is 3.1 meters per second, and your acceleration given is 4.7 meters per second squared. So don't confuse this with acceleration due to gravity. Those are not the same thing. Oh, but here's the thing. Well, we don't know our final velocity, we don't know our final position, and we don't know time for actually either of these. But here's something that will come handy when tackling such problems in the future. We know that they started off at the same time. If they started off at the same time, the time for object A should be equivalent to the time for object B. So the time for object A is the same as the time for object B. And you'll see in just a second why this comes handy. So we're going to treat these as two different objects in two completely unrelated situations. Now we're going to write the equations based off the ones that were given for both of these. Well, if you take a look, you should have the equations noted down. We're going to use x is equal to x of 0 plus v of 0t plus 1/2 at squared. We're going to use that for both objects. So just go ahead and write that down. Just make that clear. Plus 1/2 at squared. Now let's plug in everything we have given. So we don't know what x is, but you'll see in just a second why that's actually irrelevant. So we'll just say x is equal to 0 plus 5.5t plus 1/2 a, and we'll call this t of a because it's up for object a, squared. And over here we'll say x is equal to 0 plus 3.1t plus 1/2, and since this is object b, actually, give me just a second, we can actually replace the accelerations that were given. So instead of using a, let me just go back and plug in those accelerations. So 1/2 times 2 times t of a squared, and over here 1/2 times 4.7 times t of b squared. Now notice that you have two equations that are given that equal the exact same thing. Well, if you recall your algebra or basic math skills, what can you do in a situation like this? This is equal to x, and so is this. So you can actually set the two equations equal to each other. We'll just take out the zeros since that doesn't do anything, and we get 5.5t plus, well, 1/2 of 2 is just 1, so we'll just have t of a squared is going to be equal to 3.1t. Now, what's half of, we'll just call this 4.7 over 2 because of the decimals, times t of b squared. Now here's the thing, t of a is equal to t of b. So these are not two different unknowns. I'll just call this, t of a and t of b. So since they're interchangeable, let's just call the t of b, let's just change this to t of a. So what do we have? We have 5.5 t of a plus t of a squared is equal to 3.1 t of a plus 4.7 over 2 t of b squared. Now you can actually just combine like terms here. So 4.7 divided by 2 is just going to be 2.35. So this is 2.35, and we'll bring the t of a over here. So this becomes 2.35 minus 1. So we have 1.35 t of a squared. Don't forget the squared. Now we'll move this over here just to make it easier and avoid negatives. So what's 5.5 minus 3.2? That's going to give us 2.3. Is equal to 2.3 t of a. Now we can cancel out one of the t of a's here, and we get 1.35 t of a is going to be equal to 2.3. Now solving for t of a, we get t of a, which is the same as t of b, is going to be equal to 2.3 divided by 1.35. And this gives us a time of 1.70 seconds. So what does this tell us? This tells us when after 1.70 seconds, or just 1.7 seconds, particle B is going to actually surpass particle A. Now, you might be wondering why particle B surpasses particle A. Well, while particle A has a higher velocity, particle B is accelerating faster. So hence, at some point, it is going to pass particle A. And this question is asking at what time does that point occur? Now keep in mind, it's not asking for the position, but if we wanted to figure out the position, now we know our t, so we can just plug it back into either equation and we get the position as well. But now we know the time at which particle B surpasses particle A. So how would you do problems like these? Well, whenever you have multiple objects, you want to split those multiple objects into their own knowns and unknowns, and then you want to create an equation for each individual object. So most likely you won't get more than 2 objects on a test question, but in the case that there could be possibly 3 or 4, it could be very annoying, but you have to do it. If you don't do it, a lot of information can get jumbled up and you can make a lot of mistakes along the way. Now once you have the equations, once again, check your unknowns, plug them into the equation, and you can just go ahead and solve. But the key takeaway I wanted you guys to learn from this question was that there will be problems where you have shared variables. Now, if you hadn't noticed this, that they've left at the same time, and if you didn't know that TA is equal to TB, right, maybe you had another question mark here. If you take a look at the equations you've written down, you have 3 unknowns, which means in every single possible equation that's given, you would have at least 2 unknowns. So this is a major hint that you have misidentified one of your variables, one of your unknowns to be specific. So we can just confirm that we misidentified, because if T of A is not equal to TB, we wouldn't be able to solve the problem. So we'll probably spend about one more video going over some hard 1D kinematics questions, and then we'll go ahead and dive into 2D kinematics.